Okay, first of all, we're going to cover z-scores today, and we're going to cover the last of the empirical rule. Now, I've told you the empirical rule is very important, okay? I've told you what page it's on, and I've also put in recordings, in 2 recordings. So, you've got what you need to do the empirical rule. All right? The empirical rule says that the mean is in the middle. The mean is right here. Well, let's say the mean is 100. The mean is equal to 100. Whatever the mean is equal to, you put it in the middle. And then you add the standard deviation. Let's say the standard deviation is equal to 20. And I just made those 2 up. Then this is going to be 120. This is going to be 140. This is going to be what? 60. You add on the right. Remember the number line that you grew up with? The number line says, on the right you what? You add. On the left you what? Subtract. So that'll be 80, 60, and 40. That noise is getting on my nerves. All right. The empirical rule also says 34%, 34%, 13.5%, 2.35%, and 0.15%. 13.5%, 2.35%, and 0.15%. And what page did I tell you this was on? Was it 132? And I told you to also Google what? Normal distribution, and put, you can also type in empirical rule, and it will give you all kinds of what? Images that you can copy, put them on your sheet of paper, put 8 of them, 6 of them, and then run 10, 15 copies. That way you don't have to what?
Draw them out.
You don't have to draw them out each time. Now, one of y'all will do that, and I appreciate it. The rest of you will complain about drawing it 15,000 times. Okay? Now, the problem I'm going to show you today is a problem that is also in Math 103, it's in 120, and it's on standardized test questions. All right? And I'm just going to erase the bottom, and I'm going to just tell you what the question says. The question says, blah, 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 normal curve with a mean birth date. I think it says birth date. I can't remember. Did y'all write it down? What did it say with a mean one? Huh?
I'm talking about last class.
Yeah. What did it say?
It said, which one? The first one?
Yeah.
The length of that one? About the pregnancy?
Yeah. What did it
The
say?
length of pregnancy terms for a particular species of mammal are normally distributed about a mean pregnancy length.
Mean pregnancy length. Okay, that's what it says. Mean pregnancy length. Write that down. Mean pregnancy length. I didn't have time to Google it and pull it in. Mean pregnancy length. I can't spell it. I can't say it. Mean pregnancy length. And read the rest of it.
With a standard deviation of 12 days.
There you go. Standard deviation of 12 days. Now I'm going to ask you a question here. I'm going to say, what is the probability of the baby or whatever is being born within 12 days? That's the question. Now this is a test question. And it's also a standardized test question. And the word that's going to get you is within. That's the word that's going to get you. Remember, as I told you, in Math 120 and 103, in probability and statistics, the math is not what messes you up. It's the what? The reading. And that word within messes you up. Why? Because we as people, do we think in terms of the right hand of the number line or the left hand of the number line? We think in the positive. All right? If I ask you to plot 5, you're going to plot 5, and I don't give you a sign, you're going to plot 5 on the right-hand side of the number line. Every time. You don't say, well, I think I'll plot -5. Nobody ever does that. Okay? So, you would say 34%, and that is wrong. Okay? Because when are we born? We are born on 0 days. Right? Think about it. When you come out, what does the doctor say a week after? Okay, he's 7 days old. Okay, where did that start from? When you're born, 0. 0 days, right here. Because after this, you're born 1, 2, 3 days after the due date. So, anytime you're given a due date, the due date is represented by 0 days. And that is one of the false assumptions on this problem. Students don't know what to do because they don't think. Okay, we're talking about pregnancy length and pregnancy. What is the goal of being pregnant? Having a what? Having a baby. So having a baby falls on the day that you have the baby. Okay? Before having the baby, before the due date, is called premature. After the due date is pretty much normal, or whatever. Whatever, I don't know, I'm not a pediatrician or whatever, I don't know the terminology. But this is before, and this is what? After. So, the question says, what is the probability within 12 days? Well, I will highlight the correct answer. The correct answer is what? 68%. Because what do you do on the right-hand side of 0? You add 12. So that's 12, that's 24, that's 36. What do you do on the left side? -12, -24, -36. And that's the empirical rule. That's how you do the empirical rule. You add on the right and subtract on the left. And that is a test question. You will see a question like that on the test. And I usually put the pregnancy question on there for that one reason, because you have to think and say, well, they don't give us a mean. Well, there's no mean on pregnancy because the due date is the day that you're supposed to have the baby. And what do they ask you? You know, pediatricians, they want you, if they say the due date's 29th, then they probably are going to make you go on the 29th. You know what I'm saying? Okay, because that's when they, especially now with the ultrasounds and everything, they pretty much can tell you where the birthmark on the baby is, much less everything else, and they know when that baby needs to be born. Okay? So, your answer is 68%. 0.68 or 68%. So what if I was to ask you, what is the probability of being born 24 days or more after the due date? After the due date. Notice I said after, I didn't say within. What's another word? Instead of after, what's another word? Before. So you need to look for after, before, or what? Within. On this type of question. Now you're only talking about one question, so don't fret over it. Now, the empirical rule is going to follow you throughout this whole course. So I would suggest you go to Google and you print them out so you don't have to draw it 15,000 times. Yes, ma'am.
Now, when I say within 12 days, does that also include the negative 12 and the positive 12?
Within.
Okay.
That's what I just said. Remember? What would it say if I didn't want it within? It would say before, or it would say what? After. You get it? You gotta watch these type questions. Okay? All right. Now, I'm gonna move over to the Z-score now. And since I don't have time to pull up stuff, and I'll tell you why in just a minute, okay? I got a major announcement for this week I need to tell you, but I ain't gonna get into it right now. All right, so if I give you a problem and I say the mean normal distribution, mean is equal to 100 and the standard deviation is equal to 20. When you see these three things together, write this down. When you see these three things together, this all translates to draw the what? To draw the curve. That's what it means. And you're going to see it in the last part of this chapter, and you're going to see it the rest of the semester. Except for probability. Probability, we kind of go to a different stretch, then we go back to statistics. Okay? So, let's draw the curve. Now, there's going to be one or two people in here that invented the curve and that says, I don't have to draw it. Well, then don't whine when you get every one of the problems wrong in chapter 7. 100, 120, 140, 160, 80, 60, 40, 0.15, 2.35, 13.5, 34. Everybody in here should know these numbers. You should already know them. Why? Because I gave you this like 2 or 3 days ago, or I know I gave it to you last week. 34, 13.5, 2.35, and 0.15. Now, we're going to add this. We're going to introduce the Z-score. Z-score, why do we have the Z-score? Because we know how to do this. The Z-score is used when comparing apples to what? To oranges, meaning two different things. It's also called a standardized score. Write that down. Some people call it a standardized score, but I'm going to call it a Z-score. But if you see standardized score in your homework, it means Z-score. And the Z-scores I'm going to put are like this. They're always this: 0, 1, 2, 3, -1, -2, -3. When you go to Google and you pull up the normal distribution curve, you may have the Z-scores on the bottom. That's another word you could type in. Empirical rule, Z-score, normal distribution. And you should get the graphics that have everything on it like that, this one right here that I just did. Now the question will say, the normal distribution is the normal distribution. You got a mean of 100 and a standard deviation of 20. And then the question will say, we'll do it in blue. The question will say, find the Z-score for 127. A test score of 127. That's what the question is going to ask. And it may give you two test scores and you're comparing them. A psychology test score versus an economics test score. Which one's better? Okay, you're comparing two different classes. And that's where this comes in. Now right now we're just finding the Z-score. Wednesday we'll do 2 test scores and we'll go over the test. And that plays into the announcement, but we're going to just wait on that. Find the Z-score for 127 test score. Well, you can't do anything until you have the formula. The Z-score is equal to X minus X bar over standard deviation. So this is the thing that you need to write down and highlight and say 20% of my test is going to be about that. Because 60% of your test is going to be mean, median, mode, range, mid-range, variance, standard deviation, 5-number summary, and normal distribution. So I want you to plug and chug. Now, everybody in here should be saying to themselves, well, he gave us X bar, right? He gave us X bar, and he gave us S. So what's the only other number on this board that I can use? 127. So where do you think 127 goes? In the X. Excuse me, I think the sinus season is starting, or whatever you call it. So here we go. Z is equal to parentheses minus parentheses over parentheses. And my X is 127. And my mean is 100. And my S is 20. Now, I'm sorry, but that's about as easy plug and chug as you can get. Now take your handy dandy calculator out, unless you're Rain Man. It's going to be around 1/3 because 7 over 21 is 1/3, right? So it's going to be around 0.33. But I'm going to show you something else. I don't want the answer right now. 7 over 20. And we're going to hold right now. Go back to the empirical rule. I want you to, we're going to take the blue marker. Where is 1.7? Where is 1.7 on our Z-score? It's between 1 and 2, right? So that's 1.5 right there. So would 127. 127, that would be 130 right there, right? So 127 would be, if that's 130, I'd say 120, that's 130 right there. Everybody agree with me that that's 127? Now I'm going to put a little squiggly equals with a dot over it. You know what that means? That means I'm guessing, approximately, yes. So the reason I'm doing this is because I'm using the empirical rule to tell me what my answer should be. Everybody with me? You need to start learning how to use the two together so when we get to chapter 7, you'll know how to do this. Okay? So I'm going to guess, let's see, what would that 130 be? 130 would be 1.5, wouldn't it? So, let's see, 125 would be 1.25. So we have 127, so I think it's going to be around 1.3 or something, or I'm sorry.
35.
Yeah, 1.35. Yeah. Oh, that should be 27. There we go. 1.35. So I'm going to say around 1.35. Now this is a common sense / empirical rule guess. Now why would I do that? Why would I take the time to do a common sense empirical rule test? To make sure you don't put the wrong answer down and read it off the calculator wrong. See what I'm saying? You don't want to do that, especially in chapter 7. So now, somebody take 27. Let's see, 27. 27 will go in there one time. 1 over 7 over 20. And that's going to be 0.35 over 10. Or 3.5 over 10. And that'd be 1.35. It comes out to be 1.35. Y'all check my math, because I didn't use a calculator, I just used my brain, that's all. But go ahead and take your calculator and check to see if 27 divided by 20 is 1.35. It's a miracle. And that's how you do a z-score. Okay, so here you got the empirical rule, and here you got the z-score. Let's do a nerd. You alright? You gonna die?
Yeah, alright. Hopefully.
Okay, normal distribution. Mean is equal to 60, and a standard deviation equal to 5. I want you to find the probability at 42. I want you to find the probability at 42 and the z-score at 42. Find z at 42 and then find the probability of 42. Let me just rewrite this because I just screwed it all up. This is how you'll see it written. I want you to find z, so 42, and then find the probability of z at 42. So you got 2. And the probability is just going to be a guesstimate by the empirical rule. Because we haven't learned how to use the table yet. We might get into that Wednesday. No, we don't get into that until, chapter 7. I get it mixed up sometimes. So first of all, I'm going to draw the picture because I need to see it, because I don't know everything like some folks do. So 60, 65, 70, 75, 55, 50, and 45. So first thing I'm going to do is I'm going to plot 42. I'm going to take my blue marker and I'm going to plot z sub 42. And 42 is going to be right there. Everybody with me? I wish the board would be with me. Okay, so we know this is 0.15%, right? So I'm just going to go through, since this is 40, let's do a third. That's going to be 0.40 right, 40 right here. So in between 40 is going to be 42.5. I said 42. 42.5 is going to be right in there. So I'm about, what's half of 0.15%? 0.075%, Hubert. That's right. So I'm going to say that the percentage right here is 0.075. 0.075. Okay? 0.075%, which is very small. Okay? Now, I shouldn't have to tell you how I found 0.0575. It's half of 15. 0.15. Here it is. 0.15. 0.15 is from here to here, because you know the empirical rule. So if I'm halfway between 0.15%, what's half of 0.15? 0.075. So that's B. Now let's find that z-score. Here's 42, but we got to find that z-score. So we got to plug it in. So z at 42 is equal to 42 minus 55. Oh, I'm sorry, minus 60. Minus 60 over 5. And what's 42 minus 60?
Negative 18.
Negative 18 over 5. Now let's look at this is 0, this is negative 1, negative 2, negative 3, negative 4. Our point is past negative 3.5, so I'm going to say negative 3.6. I'm going to say approximately negative 3.6. Okay, so somebody take 5 and divide it into 18 for me.
3.6.
Negative 3.6. This is a miracle. Questions, right? Complaint. So the empirical rule works hand in hand with the z-score. You got to know both of them. So let's look at what we got to know for this test. So therefore, you can go back and look at the videos and watch over what you need to watch over. 10 to 20% of this test is going to be definitions. And I'm probably thinking about 5 or 6 right now. And I've told you those 5 or 6. Can y'all name them? What are the definitions that I would probably ask you?
Mean.
Mean?
Median.
Median? No, that's on the 80%.
Mid-range.
No, I'm talking about chapter 1 and 2. What?
Variance. The curves.
Chapter 1 and 2. I heard statistics. Lowercase statistics versus uppercase statistic. What else? I can't hear you. Yeah, I won't ask you that on the test, but that's a good one to remember.
The sampling methods.
Yeah, I don't ask those. I do ask for random sample. What's the definition of a random sample? Everybody has the what? Equal chance. Discrete versus continuous. Qualitative versus what? Quantitative. Parameter. Population. Lowercase statistic. Sample. Those are the 5 or 6 that I usually ask. Okay? And random sample. And okay, what's left? Well, that leaves 90 to 80%. So I'm going to just go ahead and say 60% is going to be mean, median, mode, range, mid-range, variance, and what? Standard deviation, along with the normal distribution, which I'm going to just put the normal curve and I'm going to put ER in it for what?
Empirical.
It's a miracle. Empirical rule, and 5 number what? With what? No. What comes with the 5 number summary? Box plot. You're probably talking about one question there. The rest of them will be these questions. Now, am I going to ask you for all of this information with each question? No. Some of your homework questions, they ask for everything. Some just ask for the range and the variance. Remember, I'm not going to ask you A through Z. I'm not going to ask you those questions. I'm not going to give you 2 sets. I may give you 1 question with 2 sets. I usually don't do that. I usually just ask you, here's 5 numbers, give me this. Here's 10 numbers, give me this. Here's 8 numbers, give me this. You with me? I try not to get into the complicated. Okay, that's 80%. So 20% is going to be z-score / empirical rule. So you've got an overlap of the empirical rule. The empirical rule can be used with many different applications. It is imperative that you learn the empirical rule. What do you mean learn it, Hubert? Well, you learn to draw the normal curve, put 0, 1, and 2, 3, -1, -2, -3, draw the percentages in, and know that what falls, remember the colors? 95% is normal. Outside of 95% is unusual. Outside of unusual is what? Outlier. That's how you learn. And then whatever mean and standard deviation you have, you fill out the bottom. Okay? That's the test. Now, why am I showing you the test? I ain't showing it to you yet. Wednesday, I want everybody to write this down so you don't screw it up. Wednesday, we will go over, we'll finish these scores with two tests. With two tests, meaning like you made a 72 on this test and a 52 on this test. Which one's the better grade given the class average on one and the class average on one? That's how you use the Z-score. Okay? And we will go over the pretest. That will leave Friday no class. Okay, I've got a conference to go to in Atlanta. I won't be here, and since it's going to fall on a test, there's no sense in me doing a video or trying to Skype in, and I can do that. But since we're so close to a test, I figure it might behoove y'all. That'll give y'all another day to work on homework and tests, because I'm going to extend it to, like, the homework will probably be extended till Monday, giving y'all another day of questions. It'll cut off Monday at midnight probably. Okay? So, everybody understand? So that means the next class, we're going to go over Z-score. We're going to go over the test. I'm going to pull it up in class. I'm going to assign the dates for the test and assign the dates for the homework. So all you squirrels, all y'all can go run around and be happy because you've got a date to turn in your homework. Okay? Who's got questions? Y'all are welcome for a free day this week. I'll probably get fussed at, but I hate it. All right. I'm going to shut down the recording. Skype, do you see all those? Any questions? They're not going to talk. They're probably going to went back to bed. I'm going to stop the recording.